See, this ddx is essentially an operator, and could henceforth we will designate this by d. We'll designate this by capital D. So when I say d2 dx2, it's like d acting on d, which is like d acting twice, d squared, which is like d acting twice, we say d square. So similarly, the nth derivative with respect to x is like d acting n times. We call it d acting on d, acting on d, acting on d, and so on and so forth, right? That's the symbolism that we use. Now, so d is essentially a differentiation operator, right? And if c is a constant, then c will come out. So that's going to be c d times v, y, d times y, right? D acting on y. D of y1 plus y2 is going to be d of y1 plus d of y2, d of y1 plus d of y2 kind of a thing. So those are essentially rules of differentiation which you already know. Now we'll just put it in a more ornated framework, the entire thing in terms of the operator. So suppose I have dy dx minus alpha y, dy dx minus alpha y, right? Kind of a thing, this kind of an expression. This is like d acting on y minus alpha y, d acting on y minus alpha y, which I choose to write as d minus alpha acting on y. It's like d minus alpha acting on y. This is what I do. Right? Dy dx minus alpha y, which is like d acting on y minus alpha y. So this I can write as d minus alpha acting on y, which is d of y minus alpha into y. Right? That's the notation we follow. This is what it means. Right? Now, what I want to share with you is, Bolo? Confusion? So d minus alpha is also an operator, and the meaning of d minus alpha means this. It means d acting on y minus alpha acting alpha into y. This is what it means now. So I'm telling you the meaning of this notation right now. I'm telling you the meaning of this notation, right? Now, when I say d minus 1 into d minus 2 acting on y, y could be, say where d is ddx, say d is ddx. Suppose this acts on x cubed. Say this acts on x cubed. What it means is that d minus 2 first acts on x cubed, d minus 2 first acts on x cubed, and then d minus 1 acts on the output of this operation. You know, this is what it means. There is an output of this operation. What's the output of this operation? D minus 2 acting on x cubed is like d dx of x cubed, which is 3x squared minus 2x cubed. 3x squared minus 2x cubed. Yes or no? Differentiate x cubed with respect to x, 3x squared minus 2x cubed. This is what it means. Confusion? So first let me replace the output of this operation. D minus 2 acting on x cubed is 3x squared minus 2x cubed. D of x cubed, see this is d of x cubed minus 2x cubed, just in case. And derivative of x cubed with respect to x is 3x squared minus 2x cubed. Yes or no? So now d minus 1 acts on what? D minus 1 acts on the output of this. The output of this is 3x squared minus 2x cubed. X cube, right? Which is now like d acting on this 3x squared minus 2x cubed minus 3x squared minus 2x cubed. Right? Now, what is this? This is 6x minus 6x squared minus 3x squared plus 2x cubed. Yes or no? So, which is like 2x cubed minus 9x squared plus 6x. Yes or no? That's output? Now, an interesting thing. If I interchange these operators, see what happens. That means I say d minus 2, d minus 1 acting on x cube. Do you realize everything that I did here? Do you realize everything that I did here? Now, let me interchange these two operators and see what happens. So this is like d minus 2. Now what's the output of this? D acting on x cube, which is 3x squared minus x cube. Yes or no? Minus x cube. Now, this is like d acting on this minus twice this. So this is like d acting on 3x squared minus x cubed minus twice 3x squared minus x cube. This is what it means. Yes or no? D acting on 3x squared will give me 6x minus 3x squared minus twice 3x squared minus x cube, which is 6x minus 9x squared plus 2x cube. Is it the same? Is it the same? That means I interchange these two operators and the output is the same. The output is the same. In fact, look, so far so good, right? In fact, what I do is, and see, it's still going to be the same. Can I wipe this off? Huh? Think of this for a moment, and please understand everything that I'm saying. For a moment, imagine this to be an algebraic product. Imagine D to be an algebraic number instead of an operator. Instead of an operator, imagine D to be just an algebraic entity. Right? So, and think of multiplying these two like you multiply algebraic polynomials. Then what is this? This is D squared minus 3D plus 2 acting on x cube. Yes or no? Mentally imagine this and see what transpires. This is like d squared acting on x cube minus 3d acting on x cube plus 2x cube. This is like differentiating x cube twice. So first time you differentiate, you get 6x squared. 3x squared. First time you differentiate, you get 3x squared. Second time you differentiate, you get 6x minus 3x squared, so minus 9x squared plus 2x cubed. Is it giving you the same thing? Yes or no? Seems like these operators, these polynomial operators, I can multiply just like I multiplied polynomials. Imagining D for a moment, forgetting that D is an operator, imagining D to be just an algebraic entity, I could create a new operator which independently acted on a x cube to give you the same output. So one, these operations are interchangeable. These operators are interchangeable. It does not matter which one acts first and which one acts later. One. Right? 2, I can create a new operator which is just imagining this to be a product. I create a new operator and the output that it produces is going to be the same. Yes or no? Which means, you know, if I have, say, d minus 1, d minus 1 acting on y, it's like I could do this d minus 1 acting on this y, and the output of this is being acted upon by another d minus 1. Or, right, I could have mentally imagined this to be a square kind of a thing, right? And then for a moment forget that it's an operator, expand this binomially. For a moment forget that this is an operator, expand this binomially. I get like a d squared minus 2d plus 1 acting on y. Yes or no? You know what I'm saying? Which means now, can I wipe this off? So which means now if I can multiply operators, I can also factorize operators. That means if I had say d squared minus 5d plus 6 acting on y, this is an operator. This is an operator. D squared minus 5d plus 6 is an operator, which is like d squared acting on y, and then minus 5 times d acting on y plus 6y, right? I could have said this is the same as d minus 2 into d minus 3 acting on y. I could have done this. I could have done this. I can factorize operators. I can multiply them like I multiplied ordinary polynomials. Acceptable, right? Yes or no? Sounds all right? Can I wipe this off?